Welcome to David Alexander Maths Tuition. This is chapter 13e, areas under curves. So we can use integration to work out the area underneath a curve. So here we need to find the area between the curve, which is shown here, the x-axis, so obviously that is the x-axis, the line x is -1, so this line here, and the line x equals 4. So we are trying to work out all of this area here. So all I need to do is integrate minus x squared plus 3x plus 4 dx between the limits of 4 and -1. So let's integrate this first of all. So that's going to be minus x cubed over 3 plus 3x squared over 2 plus 4x. So this is a definite integral, so no plus c, and that is 4 and -1. So we're going to have two brackets with a minus sign in between. So I'm going to grab my calculator, I'm going to chuck in 4, hit equals, and then when I press answer, that will recall 4. So minus answer cubed divided by 3, plus 3 answer squared divided by 2, plus 4 answer, that is 56 over 3. So it probably would have been a good idea for me to write this out with the number 4, and so minus in brackets 4 cubed over 3 plus 3 lots of 4 squared over 2 plus 4 or 16 or something like that. So that is 56 over 3. Doing the same again with -1, putting -1 into my calculator, hitting equals, and then I'm going to recall it with the answer button. So minus answer cubed over 3 plus 3 answer squared over 2 plus 4 answer, and I'm getting -13 over 6. So 56 over 3, take away minus 13 over 6, so in other words plus 13 over 6, and that will give me 125 over 6 units. So that is the area of the shaded, or this region here. Okay, here's another example. So we're finding the area between the curve x squared minus 2x minus 3, which is shown the x-axis, which we know is here, and the lines x equals 3. Actually, the scale's a bit dodgy here, hard to see. So 0, 1, 2, 3. So this is the line where x is 3, and the line x is 5. Okay, so we are just working out this little slice here. So again, what we need to do is integrate x squared minus 2x minus 3 with respect to x, upper limit 5, lower limit 3. So let's integrate this. That's x cubed over 3 minus 2x squared over 2, so minus x squared minus 3x, and that is between the limits of 5 and 3. So that is 5 cubed over 3 minus 5 squared, which is 25, minus 3x, so minus 15, take away 3 cubed over 3, which is the same as 3 squared, so 9, minus 3 squared, which is 9, minus 3 times 3, which is 9, so that is minus 9, so plus 9. So let's just deal with the left-hand bracket. The numbers were quite nice here, so 5 times 5 times 5 divided by 3, minus 25 minus 15 equals, that is 5/3. And if I add 9 to that, I'm getting 32 over 3. So 32 over 3 units is this area under the graph there. Okay, here's another example. You probably don't need another example. This is quite similar to, I think, the first question in the book, where there's no sketch. We've just been told that we're trying to work out the area between the curve. So we've got 3x squared plus 5x plus 7, and it's between the lines x equals a and x equals b and the x-axis. So so we've got the lines here, x equals 2 and x equals 7. So well, who knows, it's probably that sort of area. Again, we just need to be careful as to whether this this curve here goes beneath the x-axis, and in this case it doesn't, so there's not really there's no real problem here at all, but that's something you might need to consider with harder questions. So this is just the introductory chapter to areas under curves, really, before we start stressing about areas underneath the x-axis, which we'll move on to, I think, in the next chapter. So again, all we're doing here is we are integrating 3x squared plus 5x plus 7 with respect to x between the limits of 7 and 2. So let's integrate 3x squared, that's 3x cubed over 3, so x cubed, plus 5x squared over 2 plus 7x. Oops, it should be the square brackets there. Upper limit 7, lower limit 2. Okay, so that is going to be 7 cubed plus 5 times 7 squared over 2 plus 7 sevens, which are 49. Take away 2 cubed plus 5 times 2 squared over 2 plus 7 times 2, which is 14. Okay, so let's deal with the top bracket first. So 7 times 7 times 7 plus 5 times 7 times 7 divided by 2 plus 49. That is 1029 over 2. Take away 2 cubed, 2 times 2 times 2, plus 5 times 2 squared over 2. So 2 squared over 2, that's just 2. So plus 5 times 2, so plus 10, plus 14, and that is 32. So it's 1029 over 2, subtract 32, and I'm getting the answer of 965 over 2. So when you're doing A-level maths, you need to show all these calculations here. In reality, well, you're definitely going to continue to do this, of course, but you want to know you've got the answer right, and we can use our calculator here. It's really, really easy. I probably should have shown this in the very first example. This button here is your integration button. So literally just press that button and type in the equation. Not the integral, but the original equation. So just type in 3x squared plus 5x plus 7. So this is the x button here. So 3x squared plus 5x plus 7. And then you just have to hit the down and the up button so that you will get your upper and your lower limits, and just press equals. And if you're getting 965 over 2, then you know you've got it right. If you don't get 965 over 2, then you've obviously done something wrong. So let's say your calculator says it's 965 over 3, then keep working, keep having a bash at this until you finally get 965 over 3, if that's what your calculator is saying is the correct answer. But I think you'll find if you do type this into your calculator, you will get 965 over 2. So always check your integrals using that button on your calculator. But don't rely on this just to get the answer. You need to show that you've integrated it, and you need to show that you know it's one bracket minus another bracket, and get your total. So you need to do it manually, but just double check it using your calculator, of course. Okay, find the area of the finite region between the curve with equation minus x minus 3, x minus 2, and the x-axis. Okay, so first of all, this equation is negative x squared minus 3x plus 2x plus 6. So it's negative x squared minus x plus 6. Now, where does it cut through the x-axis? Well, if we were setting this to 0, this would give us one solution of 2, and this would give us a solution of negative 3. Okay, so what we are doing, we've got a curve, and we know that it cuts through at negative 3 and 2, so we are working out this area here. So what we need to do is integrate this with respect to x, upper limit 2, lower limit negative 3. So let's integrate this first of all. That's going to be negative x cubed over 3 minus x squared over 2 plus 6x, square brackets, upper limit 2, lower limit negative 3. So that's going to be minus 2 cubed over 3 minus 2 squared, well, which is 4 over 2, which is 2, plus 6 times 2, which is 12. Take away negative minus 3 cubed over 3 minus so that's minus 3 squared over 2 plus 6 lots of negative 3. Okay, so let's just do the first bracket first of all. So we have, all the minus symbols can cause a problem. So what I tend to do is, as I've done in previous examples, just put 2 into my calculator, hit equals, and now press answer. So I'm just using this formula here. So I'm going to do minus answer cubed over 3 minus answer squared over 2 plus 6 answer, and that is 22 over 3. Take away, now I'm putting in negative 3 in my calculator, so now I can just forget about that negative symbol completely. So going back to just the original integral here, so I'm going to do minus answer cubed over 3 minus answer squared over 2 plus 6 answer. What am I getting? Minus 27 over 2. Okay, so 22 over 3 plus 27 over 2. I'm getting 125 over 6. So that is the area, this area here is 125 over 6 units. Again, go to your calculator, stick that in, make sure your calculator display looks like that. Press equals, and if you're getting 125 over 6, then you know for sure you've got this question right.